Assalamualaikum warahmatullahi wabarakatuh. And today I'm going to present innovation in advanced material ECS 246. My name is SYAKIB and the other member are RAZIF and RAZIF. So the presentation outline is introduction definition of advanced material, methodology, method of study, findings, the more information about advanced material, discussion, the discussion for the studies, conclusion, the total of studies. So we just go to introduction. The introduction is the advanced material is a complex scientific topic that covers a huge variety of field and application. Advanced material 101 define advanced material as a convenient generic term for any new material that has been deliberately created by human beings. It's generally used to refer to a new material with high-tech application and that were developed during the last few decades. Research and the development of new advanced material for industrial application is multidisciplinary and can draw on expertise in the field of chemistry, physics, nanotechnology, ceramic, metallurgy, and biomaterial. So the next is methodology. Methodology is the fusion method. This method uses alloying element is in a fixed proportion and fuse them together in a refractory melting pot or in a brick line cubicle. The component metal with a high melting point is melted first and the other component with a lower melting point is added to. Both metal components are mixed well and allowed to melt further. The molten mass is covered by powder carbon to avoid oxidation of the molten alloy component because they are very reactive to the surrounding atmospheric oxygen. The resultant molten mass is allowed to cool at room temperature. The second method is electrodeposition method. This method involves simultaneous deposition of different component metal from the electrolyte solution containing their salt solution mixture by passing direct electricity. And the third is the reduction method. Metal may exist in the form of compound. Reduction is a chemical process in which a compound of one component can be separated from another component to get a pure metal. This method is performed in an electric furnace. The last method is powder metallurgy. Powder metallurgy may be defined as the art of producing fine metal powder and then making articles from individual metal powder or alloy metal powder. That's all for me. I will now pass it to Razi.
So I will continue with the finding. The finding that we got is a benefit of the product innovation comparison with the existing materials. Next is how the material is being used or possibility to be used in Malaysia. And last one is what is the current research and development related to the product. So we'll move on to the benefits of advanced alloy. First, the benefit to the economy is its availability. Availability is a material most important property. Even if a material is very inexpensive and has outstanding corrosion resistance, it won't matter if you can get the alloy in the product forms you need when you need them. But don't worry, because this material availability is high. And for the cost, this alloy is low on cost, so it can save the budget of all the company that using this material. Although price is always important, material costs are simply one aspect of the overall picture. For constructed equipment, design life cycle costs must be evaluated in order to properly contrast option and maximize cost efficiency. For benefits of advanced alloy to the environment is lightweight because lightweight offer quantifiable benefits like better fuel economy, lower life cycle costs, longer lasting and more corrosion resistant products, fewer environmental impacts and healthier returns on public sector spending. Interest in lighter, more fuel efficient and environmentally friendly products is rising. For benefits to the industry, this material is corrosion resistant, better solderability, which is easy to handle, durable parts, thermal conductivity, and electrical conductivity. The benefits to the community is aesthetic value to the landscape. This material is easy to modify and lower cost to make as a landscape. And it is also safe for the community place. This advanced alloy have high strength and safe from corrosion, so there is no hazard to the community.
So we move on with the how the material is being used or possibility to be used in Malaysia. First, they are most frequently utilized in the aerospace industry, whereby high-performing materials are prerequisite for safe and effective flight. Alloys mixing aluminite metals and titanium have been developed for the aerospace industry. These are even stronger than the strongest aluminum alloy and lighter than the already lightweight material. Still, increasing strength in this alloy without increasing density remains a goal for many within academia and industry. Other than that, quality and certification have always driven the choice of material for systems such as plate heat exchangers, PHE, tubing, pipes, and pump in the downstream oil and gas industry. Technical specifications ensure that assets provide process continuity over a long life while protecting quality, safety, and the environment. That is why many operators have embedded nickel alloys such as alloy 625 in their technical specification and standard. Next, what is the current research and development related to the product? Bright future for stainless steel alloy when considering all the properties and benefit of Ultra 654 SMO, high corrosion resistant and mechanical strength, price stability, and enabling accurate planning. It has clear potential to be more competitive alternative to nickel alloy. Development of advanced alloy is essential to achieve net zero carbon emission in the power sector by 2035 and the broader economy by 2050. Key goals of the Biden administration to address climate change. An ETL austenitic HEAs have been designed and manufactured for corrosion and oxidation resistance, mechanical response, lower cost, and increased manufacturability. High entropy alloy concept are used to design superalloy with a more stable matrix. And ETL is developing rogue and cast alloys for high temperature applications. For the discussion, the use of advanced material in the construction industry has been gaining significant attention and popularity in recent years. These materials offer numerous benefits over traditional construction material, such as increased strength, durability, and sustainability. As example, fiber reinforced concrete (FRC) is a type of concrete that incorporate fibers such as steel, glass, or synthetic fibers into the mixture. With addition enhance the tensile strength and toughness of the concrete, making it more resistant to cracking and improving its overall durability. Ordinary concrete without fiber reinforcement is more prone to cracking and has lower tensile strength. Next, for the conclusion, the use of advanced materials greatly benefits the engineering industry more and more. Various materials have been studied and found to be better material for use in construction work. Therefore, we need to constantly update new information and knowledge found so that the construction work will be better and will open the eyes of the world to new material systems. The use of alloys in construction has proven to be effective in improving the engineering industry in our country. It will make our country more highly regarded, and by producing new advanced material will definitely be welcome in the engineering industry. So this is the reference for our work. That's all from us. Thank you.